So many students lose easy marks in questions on magnetic fields, not because it's difficult, but because the concept isn't clear. If you have ever been confused by a magnetic field or field lines, direction, or diagrams, this video will make it super simple. So let's start with understanding the first thing, that's magnetic field. What a magnetic field is. A magnetic field is a region around a magnet where another magnet or a magnetic material feels the force. Just imagine yourself to be something like magnetic material or a magnet itself, and there is a magnet placed. So we have a magnet placed here, and imagine yourself to be a magnet or a magnetic material. So you're just walking by, suddenly you feel some force, like something is just pulling you, or maybe something is just kicking you. So if you feel that force and you see none there, that means it's a magnet and you are under the magnetic zone, magnetic region. So magnetic field is nothing but the region around the magnet where some other magnetic material or a magnet feels the force. Okay, now the next thing we're going to be talking about the magnetic field lines. Obviously, to learn to make it easier, we use some lines to draw. We draw some lines to make it more easy for us to study. So say for example, if I take a bar magnet, what all do we need to represent over there? We are going to be using some lines to represent the first thing, that is the direction of the magnetic field. The second thing is the strength, right? These are the two things we represent. So if I say the magnetic field present, this is the bar magnet, and the bar magnet will have poles north and south. These are the two poles of a bar magnet. So closer to the poles, it's strongest. So it would be like, like this. And strongest, that means they would be closer. As they move away, now they will start deflecting. So they will go something like that. They will start moving away. So can you see the distance? Like over here, they are closer, but there they are further apart, isn't it? What does it show? It shows that this region shows a strong magnetic field. Strong. It's strong here, whereas that region, like away from the magnet itself, we get it weaker. Right? Now, how to draw the magnetic field around a bar magnet? So, let me draw a bar magnet here. This is north and that's south. The first thing to remember is the magnetic field line. So we'll be using some curved lines, like actually it is like this. So your north and south poles are going to be getting it quite, strong. And then it starts to deflect. So when it deflects, we just show it like that. Something like that. And down there, the same as well. Right? Let me draw a few more circles to show you the magnetic field lines. Okay, so these are the magnetic field lines, and what we need to do, we need to strength already we discussed. Now we are going to be talking about the direction. So direction is always away from north towards south. So you will just draw arrows like that. See, they all are pointing towards south. Yeah. So this is what we have to do. So away from north towards south. That's it. Hope that makes sense. So towards south, so if it comes, it will come and go like that, isn't it? So that will also come and go like that. So here we'll show like this and it'll go away from north. So it will be like that. Hope that makes sense. So this is what the magnetic field around a bar magnet. Now, if I talk about a magnetic field around a current carrying wire, we also learn about, because we are talking about magnetic field, that means wherever it is present, we'll discuss that. So if I say the magnetic field around a current carrying wire, how will that be represented? Say for example, this is a wire. It's a thick wire. Oh, not bad. No, it's a thick wire and we're getting the current flowing through. So this is the current flowing through, going upwards. Okay, so that's the direction of the current. You know, it will also produce a magnetic field. The magnetic field will have the when the current, so let me just write it down. A current carrying wire produces a magnetic field around it. Yes, it's not a magnet around, but the wire itself, because the current is flowing through it, it produces a magnetic field. And the concentric circles, like these circles, we draw to represent the magnetic field around. Now, obviously, two things are very important: strength and direction. So, closer to the wire, we will have strong magnetic field. Away from the wire, so like here, you will experience weaker magnetic field, weaker, whereas there, like here, you will feel a stronger magnetic field. Now, the second thing is the direction. So we use we use right hand rule. So right hand, like this is the thumb and these are the fingers. Like, you know, I'm not that great at drawing, but yeah, say for example, okay. So these are the fingers, and we use the right hand rule to identify the direction of the magnetic field. So the thumb points the direction of the current. You would be just using your thumb to point the direction of the current, and fingers point the direction of magnetic field. So the magnetic field is going like this, isn't it? The direction of magnetic field would be like that. Just use your right hand rule. Use your right hand to understand that. The thumb points towards the direction of the current, and the fingers point towards the direction of magnetic field. Let's talk about solenoid. Solenoid is nothing but we are just trying to make a stronger magnet. So for that, how about, this is a wire. Let's just twist and turn the wire. So if you take a wire and start turning it to make a loop, like, coil, turn and turn, keep going. Okay. It will have the current flowing through it. This is nothing but the solenoid. And solenoid acts as a bar. It is as strong as a bar magnet. Right? Okay. If this is the direction of the current entering in, so the entry of the current shows the north pole, and the exit of the current shows the south pole. Inside, we're going to be getting a uniform magnetic field. Uniform, that means they would all be parallel. Like, how do we show the uniform magnetic field? Uniform magnetic field. You just need not to do anything else but draw the lines which are parallel to each other and equidistant. Like, they all should have equal distances. That's it. That represents a uniform magnetic field. So inside, we're going to be getting a uniform magnetic field, and yeah, we are going to be making loops there, something like this and something like that. Let's make 2 up and 2 down, and yes, the direction is always away from north and towards the south. So away from north towards the south, it will be like that. Here as well, away from north towards south, away from north and towards south. That's nothing but a solenoid, right? So everywhere we were just talking about the magnetic field, right? I hope it makes some more sense. Let's talk about exam tips. It's very important to take field lines, and field lines, the direction should be north to south. Just drawing curved lines or straight lines doesn't work if you don't show the direction. Your arrowhead is going to be representing the direction. So field lines always go from north to south. Closer the line, stronger the magnetic field. Away, like distant apart, that means weaker the magnetic field. Remember, field lines never cross each other. We use arrows to show the direction, right? And if you get something like describe, you need to use keywords, good keywords in your answer. Keywords are going to be giving you marks, right? Once you understand these rules, questions become easy. Focus on rules, keywords, and clear diagrams. If you need structured support in maths and science, subscribe to our channel Excel Math. We make concepts simple and exams easier. Thank you.